Lesson 8.6, Graphing Linear Inequalities. Now we're going to take a step into something a bit more interesting, but it's not that new. Actually, if you remember that when you graph on a number line, that's a very ugly number line, I'm sorry, but if you have something like this, and I said graph x is greater than 2, you'd find 2, you look at the inequality and ask yourself, am I going to put a circle or a solid dot? In this case, a solid dot. Then I have to decide going right or left. In this case, I go to the right. Now that may not ring a bell, but that is kind of the same idea we'll need for graphing linear inequalities. The difference is, instead of having one axis, like we have right here, now we have two. We have a y and an x. So the process is pretty similar, so I'll take you through it. First of all, you do exactly the way the things you've been doing in the past. Graph your y-intercept, which is 4. Your slope, if I write this more clearly as a fraction, is this. So down 1 over 2. And then you have a decision to make. Just like down near here, you have to decide, is it a circle or a solid dot? Here you say, if it's greater than or less than, I do a dotted line. If it's greater than or equal to, or less than or equal to, I draw a solid line. So in this case, because this has no line under it, it will be dotted. Big difference when it comes to inequalities. And just like down here, where you have to decide, am I going to go to the right or to the left? On this one, think of the line you've drawn as a railroad track. You have to decide if you're going to shade one side of the railroad track or the other. And the quickest way, well, there's two ways to do it. I'm going to show you both. Here's the point 0, 0. If I plug 0 in for y and 0 in for x, do I get a true statement? I get 0 is less than, -1/2 times 0 is 0, and I'm left with 4. Is 0 less than 4? That is a true statement. So since it was true, and the point was on this side of the railroad tracks that you just drew, I would shade this whole side. Any point that's shaded here would work if we plugged it into the inequality. In other words, you would get a true statement. The second way to look at this is to say my y values get greater as I go up and less than as I go down. And this is asking you what y's are less than the line you drew. And that would be down. A little bit more intuitive way to do it. Don't expect you to do one way or the other. It's up to you. Plug in 0, 0, or interpret it as what does less than mean. Let's try another. The y-intercept in this case is nothing. So the y-intercept is 0. The slope, if there's nothing there, is a 1, and we can write that as a fraction, 1 over 1. The inequality has a line under it, so it's going to be solid. Now notice this line goes through the origin, so I can't plug in 0, 0. But the only reason I had plugged in 0, 0 before is because it's an easy point to plug in. But you could plug in any point that you want. In this case, 1, 0 could be plugged in even. But I'm going to look at this the way I did before in the second approach. I want to ask you which y's on this axis are greater than or equal to the line you drew. Again, y's get greater as you go up and less than as you go down. So the y's that are greater than this line you drew are up here. So all those would work. But just to verify, let's say I did plug in the point 1, 0. 1, 0 has x value of 1 and a y value of 0. So 0, x is 1, is 0 greater than or equal to 1? No, that is a false statement, and that is why we are not shading that side. So quite a few things to think about. So now look at these two, or these three equations. These are a little bit different, but we've seen them before. Y is greater than or equal to 3. Well, we already talked about what does y equals 3 look like. And we said that was a horizontal line at 3. Now when it becomes an inequality, we have to ask ourselves, is it solid or dotted? In this case, it is solid because it has a line under it. But now we have to shade, above or below. And again, what y values are greater than or equal to that line? That would be up. Okay? Next one, x equals 2. Well, we've already talked about these as well. That happens to be a vertical line. Now the difference here in this one is that I'm done. It's equal to, so there's no shading necessary. It's just the line at 2. If I change it to less than or equal to 2, now we're talking about something else. That one would look like that line. It's solid because there's a line under it. You would shade less than. Now this is x-axis. You're more familiar with x. What x's are less than 2? Everything on this side. So that's how you would handle vertical and horizontal lines. Let's look real quick here at this and ask ourselves, would you have a dotted line, a dashed line, or a solid line? Line underneath it? Solid. No line underneath it? Dashed. Line underneath it? Solid. No line underneath it? Dashed. Now say if we were going to shade above or below. Less than or equal to. As y's go up, this is greater than. Y's go down, this is less than. What y's are less than? We'd shade down. What y's are greater than? We shade above. What y's are greater than? Above. And then what y's are less than? Below. And if you didn't know, these are greater than and greater than or equal to. This is less than, or less than or equal to. Alright, and that ends the lesson for 8.6. That's all I have for you. So go ahead and do the assignment that's been given. You have your worksheet questions as well as some book questions. Good luck, and I'll talk to you on Monday.